Boston, happy to be here, talking about climate change and the impacts on extreme precipitation in particular. But I always like to start with this slide. In the 2007 release of the Fourth Assessment Report, the IPCC was very strong in their wording about climate change as unequivocal, and that human emissions were very likely or highly likely to be a contributing factor to those. But I think I'm preaching to the choir here, so we won't talk about that much. And also, the future that we're going to be facing has a lot to do with how much our emissions will be in the future. So, of course, mitigation efforts are key in reducing the impacts in the future. But I got this slide when I gave a talk at a Boston insurance workshop. And, of course, we know that predictions are highly uncertain. There's a lot of things that affect what our future could look like, including our human emissions and our behavior. But that is not a reason for inaction. So we have enough information. The climate models have been good enough to let us know what the future could look like, that we need to be acting now. So I'm going to talk about extreme events, in particular talking about precipitation events. And before I talk specifically, I wanted to talk a little bit about what do we mean by extreme event. So extreme events can be defined in very different ways, but we think about extreme events by first looking at how the particular climate variable we're interested in distributes itself on the number line. So when the meteorologist on TV says the temperature was above or below normal, or our precipitation was above or below normal, what they mean is around that average value. So we have, in this case, temperature data that has been collected, and on this axis is the probability or frequency of that occurring. And so, as we would expect, for temperature, most of our observations fall close to that mean or normal range. And then we have some threshold above and below which we consider an extreme event. So, for example, a really, really hot temperature, if it falls above a certain probability, say 95% probability, or below 5% probability on this distribution, then we call that an extreme event. And so how does climate change affect extremes? Well, disregarding the fact that it could affect how this distribution looks, if we just assume that going into the future, temperature and precipitation are going to distribute themselves in a similar manner, but just shift the mean upward, then we end up, for example, with temperatures, this threshold that was once considered extreme now becomes much more likely. So we see these high temperatures that we used to think were really, really hot days as becoming more frequent, and the cold days becoming less frequent. So they fall almost outside of the range of expectation now. The same thing with precipitation. Precipitation distribution looks very different. We don't expect it to rain all of the time. So most of the time it doesn't rain. 2/3 of the time it doesn't rain. And fortunately for us, very infrequently, it rains very heavily. So precipitation distribution looks like this. And again, as climate change shifts that forward or upward, we would expect to get a fewer amount of the low precipitation events and more of the heavier precipitation events. So that gives you kind of an example of the expectation. And so really, a shift in this mean value that we talk a lot about has an important impact on extreme events in that it changes the frequency and the intensity, the spatial extent, how far they reach, the duration, in other words, how long an event might last, the timing of the event. It changes a lot of the characteristics of the extreme events that we've come to become accustomed to. And there are expectations. We've been observing increases in extreme precipitation over the last, since the early 1900s. So what the climate models have been saying about extreme events and their impact from climate change appears to be played out in the observations. And also we're expecting in the Northeast to see an increase in precipitation overall, especially in extreme events into the future. And so an assessment was done around North America to understand what climate change would be expected, what we would expect to see in climate changes. And I think, as you all know, we expect to see increases in very warm temperatures. We expect to continue to see increases in precipitation, extreme precipitation events, and even the non-tropical or the extratropical storms. There's some evidence that there's a shifting in storm tracks, and those are the storms that affect us in New England as well. So what are we seeing here in the Northeast? Well, I think that you're all probably familiar with the fact that we're seeing warmer temperatures. We're seeing, especially in the winter is really being impacted. It's increasing even quicker than average temperatures. We're seeing a decrease to a degree of some of our extreme cold days. But more importantly, of course, I'm a hydrologist, so I focus on the water end. We're seeing really dramatic changes in the hydrologic cycle. So for example, we're seeing changes in ice out date, almost an advancement of a week or two. Ice out is occurring earlier. We're seeing a decrease in the snowpack in northern New England. That may not affect you as much here in southern New England, but certainly in northern New England, the snowpack extent and density is decreasing, and that affects the rivers in the northern New Hampshire that are very dominated by snowmelt as far as the flooding goes. We're seeing changes in the timing and also in magnitude of river flows. Now, I was interested in knowing what does this mean about, what does climate change mean about precipitation in New England, and in particular, extreme precipitation. I'm an engineer, and so I'm interested in knowing how we can incorporate the effects of climate change into how engineers design for managing stormwater, managing floods, things like that. So I looked at extreme precipitation, and what I defined as extreme precipitation as an engineer's perspective is looking at the peak, the highest precipitation, one-day precipitation event in every year. And I looked for trends in those precipitation data from 1954 through 2005. I stopped at 2005 because I know we've had a few really extreme events towards the end of the record, and I wanted to see how leaving those out and putting those in influenced the trends. And so I looked at 54 to 2005 and 2008, and I also looked at trends from 1970 through those two end time frames as well, because 1970 appears to be that magical number that in New England and other parts of the world, we're really starting to see an acceleration of the hydrologic cycle. And then because I am an engineer, I wanted to see what the effect on looking at this data might have on the so-called 100-year precipitation event, which is one of the values that we use, that engineers use for designing things like culverts, bridges, things like that. And I looked at stations in northern New England. I wasn't intentionally being prejudiced or any way. This all was actually started, I live here in the Portsmouth area, and this whole analysis started while I was sitting in my house with 2.5 feet of water in my basement because of the Mother's Day storm. So I took this very personally and began, I did what any hydrologist would do when you can't do anything about the flooding. You start downloading data to try to figure out what's going on. So that's what started this, and that's how I ended up just sort of looking at northern New England. So just as an example, the characteristics we have, when we're looking at these extreme events, we have a fairly even distribution seasonally. But by no surprise, I'm sure, the majority of our extreme precipitation events occur in the latter part of the year from August through November, which is typically our hurricane season. So even though the average value of the extreme events is really fairly constant throughout the year, the number of times we get an extreme event is biased towards the latter part of the year in hurricane season. So this is a figure that shows my evaluation of trends. So you see the little open dots, those indicate I didn't find any kind of a trend, and I'm defining a trend as just a linear increase or decrease over time, looking from 1954 to 2005, and the reason I picked that time frame was simply it gave me the best spatial distribution with a continuous record. We always have to make those trade-offs. And if you see the big red dot, that means it's a highly meaningful trend. If you see an orange dot, it means it's a meaningful trend. And if you see an open circle, it means there was no trend at all. So looking at from 54 to 2005, before that series of extreme events we got, there really weren't a lot of trends. Only a couple stations in western New Hampshire and central Massachusetts showed any kind of a trend. But when I added in the latter part of the record, and of course this was done through 2008, you could see a few more of these trends, meaningful trends popping up, especially in the coastal regions. If you look from 1970, which is that magical climate change year, then you start seeing many more trends, and especially if I add in those events like the Mother's Day storm, the Patriot storm, all of these storms that are meaningful, let's say, in Massachusetts and northern New England, you really start seeing a lot of trends. And this is particularly surprising because with a shorter record, it's harder for an increase like that to be discernible from the variable record. And so even with the smaller data set, I found more trends, many more trends popping up from 1970 to 2008. So that indicates that over the long term, we haven't seen a lot of change, but in recent years, recent decades, as we've sort of felt intuitively, we're seeing more increasing trend in precipitation. And then to compare that with engineering standards, I just wanted to know what does that do to what does looking at these data do to the 100-year storm event? And in Massachusetts and along the coast, we actually see an increase of 8 inches as opposed to 6.5 inches, which was the industry standard prior to that, from this document that we call TP40, affectionately in the engineering standard. Maybe some of you have heard of that document. And I think a lot of this difference between what I found in the recent record and the TP40 document, which is the engineering standard, has a lot to do with data density. So I have a lot more stations now than they had back in the 50s to analyze. So we've seen an increase, and also we've seen an increase in multi-year events. So while I was actually finishing this paper, the 2010 events rolled through New England, and so we saw another suite of events. And the flooding always seems to occur from the multi-day events. So we need to look at the multiple day events, the 2- and the 3-day precipitation events, as well as the 1-day. Just quickly, I looked at one of the stations in Rhode Island. I hadn't done an analysis on Rhode Island before, but since I was going to talk in Rhode Island, I thought I should have an idea what's going on in Rhode Island. This is the Kingstown, Rhode Island record, which goes all the way back to 1893. And in the 1-day, the 2-day in the green, and the 3-day in the red, there do not appear to be any meaningful trends in the data thus far. And even if you constrain the record from the 1950s, there appears to be an upward shift but it's not statistically meaningful. So for this particular one record, I don't see meaningful trends in these extreme precipitation values, but the reason you look at these things spatially is because any singular station might tell you a different story, but if you look at the groups as a whole, it tells you more of the climate signal. So this is consistent with a report that was put out in 2010 by a colleague of mine at the University of New Hampshire that also looked at extreme events defined in a slightly different way. This is the 1 inch, so picked all the events that were 1 inch and greater and 2 inches and greater, and found these trends in Massachusetts, along the coast, in New Hampshire, but not a whole lot of trend in New England right now. So what are the implications? I think we all know changes in stormwater management, more flooding, damage to infrastructure and property, business and transportation disruption, and health and well-being, which I think are all issues that are going to be covered today. And of course, we all know about what we do about this. We have to continue with our mitigation, our adaptation, which is the whole reason for coming to this conference. And then we also have to work hard at quantifying what these changes mean from a risk-based standpoint. So that's my talk.